All right, hey gang, I hope everyone's doing well. I basically am making this video up because, I've talked to you about how I didn't know how the whole hybrid model would be going along. I wanted to slow things down a little bit. So we may have gotten through this entire lesson in class, and if not, or if there was something in this lesson that you didn't understand, by all means, I hope this helps to go back and look over it again to make sure you're okay. And then the homework for this is actually going to be due, I guess in this case, well, it depends on which class you are out or even, so I won't even talk about that. Anyways, I want to jump right into it here. We're still in section 1.3, and we're talking about locating points on a line segment, okay? And so we're getting into some fractions here. You see some fractions here, you see some ratios. And I know that fractions and ratios for some people can be kind of intimidating, but I hope I'm going to make it nice and simple for you. And so we're going to get right into that, and then you can let me know if you have questions or everything. So in the first one, we have this line segment MR. So from M to R is the line segment, and we want to locate a point X that is 1/3 that length, the distance from M to R. Now, this phrase, from M to R, tells me what direction I'm actually heading. So if I'm starting at M and I'm heading to R, okay, I also want to start with that fraction of 1/3 from here to there. So that tells me what direction I'm heading. If it was R to M, I would start at R and head back to M, and we'd be 1/3 direction that way. So again, know what direction you're actually heading. So I guess one thing that I did, the very first thing I did, was I found the distance from M to R. And so I can recognize that that distance is a total of 9. I have 5 units on this side and 4 units on this side. Or I could go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got a total length of 9 units there. Now, if I want to find point X, which is 1/3 the distance from here to here, I want to make sure I understand what of means, okay? And of means multiplication. So I'm just going to make a little note of that. Multiplication in math. If I have, I don't know, 2/3 the amount of money that you do, you would take 2/3 times the amount of money that you have. Okay, I'm just trying to figure out something that would make a direct correlation or a connection with you. Anyways, of is multiplication in mathematics. So what I'm going to do is I'm going to take 1/3 of the distance from M to R. Okay. Now some of you might need your calculators here, but 1/3 of 9 is 3. Okay. So this is the distance I'm going to travel from M to R. So if I go 3 units in that direction, that should give me where X is going to lie. So I'm going to go 1, 2, 3, and what we notice is that point X is the same as point N, okay? Or that point X is -1, okay? Either of those would be fine with me. But again, it's 1/3 of the distance from M to R. Now, for the next one, this one is from N to R. So we're starting here and we're heading in this direction to R. Okay? And we're actually going to go 2/3 the distance. So if I go ahead and calculate or figure out the length from N to R, that length is a length of 6. 1, 2, 3, 4, 5, 6. Okay? And we want 2/3 of that distance. So maybe I should have done this as well. This tells me the direction, and this tells me what I'm going to do. So I'm going to go ahead and do 2/3 of that distance. Well, 3 goes into 6 twice. 2 times 2 is 4, so I have to go 4 units from N to R. So if I count 4 units over, 1, 2, 3, 4, what I see is that point Y is the same as point Q, or that point Y is going to be 3. Okay, so I hope those fractions aren't so intimidating now. You're telling yourself what portion of the distance you're actually traveling to get to that point. Now, in these next questions right here, we're going to figure out with these ratios, 2/3, 1 to 2 ratio, we are actually going to figure out where on a diagonal line it's going to lie. So one of the concepts we talked about earlier was that you could count the distance from, let's say, C to D. Okay, the length of CD is equal to 2 units. Okay, just counting it, 1, 2. Or even D to E, if I was to put E right here, that length right there is going to be a length of 1, 2, 3. You can count them because they're completely vertical and completely horizontal. However, when you start to change it to a diagonal, the rules change, all right? So what I'm going to do is I'm actually going to show the slope of this segment, the rise and the run. So now we want to take a look at how this is affected if we have 2/3 the distance on a diagonal line. So again, all I did was trace the rise and the run, okay? Now, I need to know what direction I'm going. I'm going from A to B, okay? So I'm starting here and I'm heading, I'll make a little note of this, I'm heading in this direction, okay? And if you think about it, 2/3 of that distance is actually going to be, quite a bit down the way. If I was to guess, half is probably somewhere right in here. So 2/3 is going to be somewhere down in here. But how do I locate that exact point? Well, if I can go 2/3, and again, we're starting at this point here, 2/3 down and 2/3 over, 2/3 the run and 2/3 the rise, that should give me my exact location on this diagonal right here. So if I count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, I've got a length of 9 units on the vertical, on the rise. The run is 1, 2, 3, 4, 5, 6, okay? And so I'm going to take 2/3 of both of those, because again, remember, of means to multiply. So if I go ahead and do this, 2/3 of 9 and 2/3 of 6, we already did 2/3 of 6 just a moment ago. 3 goes into 9 3 times, 2 times 3 is going to be 6, okay? So if I start here and do this as my rise and this is my run, it should show me the exact location on this diagonal. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. That point right there is going to be 2/3 the distance from A to B, and I'm going to make that point X. Now, it's probably good to review ordered pairs. Remember, you can't see it very well, but this is the X, and this is the Y, and the ordered pairs always go in X, comma Y. So point X has an ordered pair of 1, -2. Okay, 2/3 of that distance there. So I hope that made sense. The reason why I started here, because we were going from A to B. If I was going B to A, I would have started here and done, 2/3 of the rise and 2/3 of the run and gotten somewhere up in there. Okay? All right, now, the next one is a little bit different. It's in a ratio. Now, what you need to understand about ratios, let me read it so that we are on the same page here. Find the point Y on AB such that the ratio of AY to YB is 1 to 2, okay? Now, I'm going to redraw this just on a line right here so you can kind of see what's going on. If we're going to break up this, Y is in a ratio of 1 to 2, what we know is that this length covered right here is doubled to get this length right here, because the 2 goes with the YB and the 1 goes with the AY, okay? So the length of AY doubled gives me YB, okay? Now, to make this a fraction, because I like to go back to the original problem right here. We've been working with fractions. Let's turn this into a fraction, okay? So if we wanted to go from A to Y, or A to B, This length is 1 out of, well, there's how many lengths? 1, and then there are 2 over here because this one's twice the length of this. So if you add these 2 together, this gives you the denominator, okay? If this was 2 to 5, the fraction would be 2 to 7 because you add the 2 together, 2 and 5 in that case, okay? So we really are asking ourselves, if we convert this back to one of these problems, that this point y is 1/3 the ratio from A to B, okay? So I'm going to take that 1/3 and I'm going to multiply it by both the rise and the run of my graph here. 9 and 6. Well, 1/3 of 9 is just 3. 1/3 of 6 is 2. Okay? So if I go down 3, the rise is 3, and the run is 2, I'm going to put a point right there. And that point I'm going to call y. I'll even put it up here, y. And y has an ordered pair of -1, +1. Okay? So I hope that makes sense to you, how I came up with this fraction, because I'm pretty sure the first 3 you were probably okay with, but I have to know how I got that fraction. Again, the numerator and then the denominator together, okay? You might ask the question, if I was to come from B to A, could I still do the same thing? Yes. B to A would be, the numerator would be 2, the denominator would be the sum of the 2, which would be 3, okay? So we already know what 2/3 of 9 and 2/3 of 6 are. We did that up here. And so if I were to do, going from B to A, up 6, 2, 3, 4, 5, 6, and over 4, that point, again, is going to be that same spot. We can either go 1/3 the distance here, or 2/3 the distance here, okay? So again, just using those ratios along a diagonal line is not hard. It just kind of changes things up, okay? Now, from there, let's see here. The last problem says this: the coordinates of the vertices of a square, RSTU, okay, these are in consecutive order, so whenever you have something that says RSTU, you can choose one of the vertices. Say I put that one as R, and then you're either going to go clockwise or counterclockwise. It doesn't matter for the next point. So if I was to go counterclockwise, it would look something like that, okay? I'm not sure how that'll look in the graph. I'll graph the points here, but we're just going to connect them in that exact order right there. So it says here that RSTU has an important ordered pair of -1, 3. So -1, 3, right there is R. The next one is S, which is at 3, 3. S. T is at 3, -1. T, and then U is at -1, -1. Okay, so from there, we're told this: find x on diagonal US. So this diagonal right here, I should have my straight edge with me. Okay, find on that diagonal, find x on diagonal US that is 3/4 the distance from U to S. Okay, so again, we're going in this direction, U to S. Okay, we're going 3/4. So if I count the rise and the run, 1, 2, 3, 4. It's a square, so this should be 4 as well. 1, 2, 3, 4. Okay, and we're going to go 3/4 the distance of that. Well, what is 3/4 of 4? Just 3. Okay. So if I'm going to go U to S, I'm going to go up 3 and over 3. And that point right there is 3/4 the distance from U to S. So I think they said to make it X, right? Yep. So we're going to be at 2, 2. So point X is at 2, comma 2. That's not a negative. That's just 2. All right. So that's it. That's how you determine points when you're given fractions or ratios. So hopefully that makes sense to you. If not, come back, talk to me in your free time, and we'll do our best to figure things out. Anyways, hope you have a great day, and we'll talk to you later.